Hello everyone and welcome back to Nile Certify. In this session we are discussing Domain 2 of Azure 104 exam, managing or implementing and managing storage. In this video we have put together some real-world style practice questions that will help you test your knowledge and see how these topics might show up in the exam. As usual, we will go through the questions. I will explain the answer in straightforward and plain language, and we will discuss why each answer is right or wrong. So hopefully this will help you prepare for your exam and gauge your knowledge before actually sitting for the actual exam. So without further ado, let's start with the first question. The first question says, your company requires a storage account that will remain available if the primary region fails. You must ensure that data is replicated to a secondary region and be able to provide read-only access to the replicated data during an outage. Which replication option should you choose? A. LRS, B. ZRS, C. GRS, D. RAGRS. So in this question, you need a storage account that stays available if the primary region fails, and the data must be replicated to a secondary region, and users should still be able to access it in read-only mode during an outage. Let's explore the options. Option A, LRS, and the LRS keeps 3 copies of your data in single data center. If the whole region fails, your storage goes down. So this does not meet the requirements, so it's a wrong answer. Option B, zone redundant storage. And with the ZRS, you spread your data across 3 availability zones in the same region. So it protects against zone or data center level failures, but not a full regional outage. And therefore, this is not enough for this scenario, so it's a wrong answer as well. Option C, geo-redundant storage. And GRS replicates your data asynchronously to a paired region. However, you cannot read from the secondary region unless you trigger a manual failover or Microsoft performs one on your behalf. That means during an outage, there is no guaranteed read-only access until failover happens. So this is also wrong answer. Option D, RAGRS, read access geo-redundant storage, and RAGRS works just like the GRS, but adds continuous read-only access to the secondary region. If the primary region fails, users can read the data without waiting for a failover of event, which actually satisfies the requirements in the question, and this is why we will select D as the correct answer in this question. Let's move to the next question, and it says you have a general purpose V2 storage account named storage1 contains several blob containers. Your organization keeps customer managed keys in an Azure key vault. You need to ensure that each container in storage1 is encrypted by a different customer managed key. Before creating the encryption scopes, what should you do first? Option A, assign and manage identity to storage1 and granted access to the key vault. Option B, enables a hierarchical namespace for storage1. Option C, create a new encryption scope for each container. And option D, enable blob versioning on storage1. So let's look at this scenario. You have a general purpose V2 storage account called storage1, and you want each container in that account to use a different customer managed key. The key live as we've been told in Azure Key Vault. Let's see option 1. Option 1 or option A suggests assigning a managed identity to the storage account and granting that identity access to the key vault. In practice, Azure uses managed identities to allow resources to access secrets or keys without embedding credentials. So when you configure a storage account to use customer managed key, you must grant the storage account a managed identity first and give it at least the key key vault crypto service encryption user role on the Azure key vault, and this will allow the storage account to retrieve the keys. So actually this is a required step we should do, but remember, like as a question asked about what should you do first. So let's explore the other options. Option B proposes enabling the hierarchical namespace. The hierarchical namespace is relevant for data lake storage Gen 2 features such as directories and file operations, but it's not required actually for encryption scopes. Even without the hierarchical namespace, by the way, you can still configure encryption scopes on a general purpose V2 account, so option B is wrong. Option C suggests creating an encryption scope for each container. This step is required actually to assign different keys, but creating a scope is not the first action. According to Microsoft Learn, the storage account must already have a managed identity with permissions to the key vault before you can create an encryption scope that uses a customer managed key. So option C is not the first one that we do, and we will exclude it now. And let's look into option D, which is about enabling blob versioning. And versioning is a data protection feature that keep previous version of blobs but does not affect encryption or the ability to set encryption scopes. So this also is wrong. Since encryption scopes that use customer managed key depend on a managed identity and key vault permission, the first step is to assign a managed identity to the storage account and grant it access to the key vault, which is option A. After that, you can create a separate encryption scope for each container and assign the appropriate key. Before moving to the next question, if you find this content valuable and if you want more resources like this for Azure 104 exam, please subscribe and like this video so you will get all the new videos that we publish. Next question. You are deploying a storage account in Azure for a line of business application. The requirements are: 1. Data must remain available even if an entire Azure region becomes unavailable. 2. The application will only read from the secondary region during outages. 3. You want the lowest possible cost that meets these requirements. Which replication option should you choose? A. ZRS, B. GRS, C. RAGRS, D. GZRS. So in this question, we are asked to choose a replication option for a storage account. The requirements are very specific. 1. They want the data to remain available even if an entire Azure region goes down. And 2, during outages, the application will only read from a secondary region, and also the cost must be as low as possible while meeting this requirement. Now let's walk through the option together. Option A, zone redundant storage, and ZRS replicates the data synchronously across 3 availability zones in a single Azure region. This is great for zone failure inside one region But if the whole region goes down, ZRS won't protect you. So this does not meet the requirement, and this is wrong answer. Option B, GRS. And GRS replicates data asynchronously to a secondary Azure region hundreds of miles away, and that gives protection against full regional outage, which matches the scenario. But before assigning this as a correct answer, let's remember that the secondary region is not readable by default. You will only get the failover. As we mentioned, you either need to initiate the failover manually, or Microsoft needs to take that action on your behalf. Otherwise, you won't be able to read the copies in the secondary region. And since the question says the app will read from the secondary region, GRS alone won't work, and this is why this is also wrong answer. Option C, read access geo redundant storage, RAGRS, and the RAGRS actually does everything the GRS do across region replication, but also it allows read-only access to the secondary region at all times. That perfectly matches the requirement that we have. The application needs the app only needs to read from the secondary region during an outages, and also the RAGRS is cheaper than GZRS, so it meets the cost optimization requirement too. Option D, GU zone redundant storage, which is basically combines ZRS and GRS, so data is stored across zone within the primary region and asynchronously replicated to a secondary region. So this is the highest resiliency you can get, but the question emphasizes lowest possible cost, and GZRS is more expensive than RAGRS, and also like the GRS is actually designed to have or to enable the read-only access. So the best option here would be C, read access GU redundant storage. Next question. You have an Azure storage account named storage1 with a container named media. User1 has the reader role at the resource group level. You generate a shared access signature token for media with read and write permission. For each of the following statements, select yes if it is true, otherwise select no. Statement 1, user 1 can upload blobs to media using the SAS token. Statement 2, user 1 can upload blobs to media from the Azure portal. Statement 3, user 1 can read blob metadata in media using Azure CLI plus SAS. This is a very good question. When we read the question carefully, the key phrases I am interested in here is user 1 has a reader role at the resource group level, and also there is a shared access signature token that was generated for the container with read and write. This tells me I must separate or pack permission used by the portal and control plane from SAS permission used for direct data access. So let's explore the statement. And statement 1 says user 1 can upload blobs to media using the SAS token. And if we thought about what SAS does, it is delegated data access that writes with the request. So if the SAS includes write, the client can upload regardless of the users are back. Reader on the resource group does not matter here. Why? Because the request uses the SAS, and this is the distinction we need to remember. Statement 1, yes, it is true that user 1 can upload blobs. Why? Because he has write permission in his SAS token. So it's correct. Statement 2, user 1 can upload blob to media from the Azure portal. Now we are in the portal, correct? The portal performs data operations using the user's RBAC permissions, not the SAS the user might have. So here what will apply is the reader role at the resource group level, which means no upload and no, like, the user cannot actually upload blobs, because the permissions that will apply here in this case when we are using the Azure portal is the RBAC permission and not the SAS. Even if the user has SAS configured or generated for him, it doesn't matter because he is using Azure portal, which uses the RBAC roles here. Statement 3, user 1 can read blob data, metadata in media using Azure CLI plus SAS. And again, this is a data plane request that carries the SAS on the command. If the SAS has read, metadata reads are allowed even though the user is only reader in the RBAC. So answer for statement 3, yes. And just like to remember, RBAC controls what you can do in the portal and management plane, while SAS controls what you can do directly against storage data. If the operation uses SAS, RBAC on the account or resource group does not limit it. Moving to the next question, which says, your company wants to allow users to map Azure file shares directly to their on-premises Windows systems. Security policies require that only the minimum necessary ports are opened on the corporate firewall. Which network port must be opened to enable Azure file share access over SMB? A. Port 443, B. Port 445, C. Port 80, D. Port 22. So let's start by highlighting the key phrase here, which is mapping Azure file share directly to on-premises Windows system. And also we can highlight minimum necessary ports. This tells us two important things. First is that we are dealing with Azure files and we are accessing it using SMB protocol, not just HTTP or HTTPS. So now let's go through the option one by one. And option A, port 443, and this is HTTPS, very common, very tempting, but Azure Files over SMB doesn't use HTTPS directly for mounting shares, so this isn't the port we need here. Option B, port 445, and actually this is a well-known SMB port, and Windows file shares, whether on premises or in Azure in the cloud, use SMB. And SMB traffic flows over port 445. That's exactly what Azure file shares requires to be open on firewall. So we will consider it as a correct answer so far, and we will keep discussing the other options. Option C, port 80, and that is a classic HTTP traffic and definitely not used for SMB shares, so you can forget this one right away. And option D, port 22, and that is SSH, usually used for Linux remote management, not Windows file shares, so another easy elimination. So the correct answer here is port 445. Moving to the next question. Your company wants to give a contractor temporary access to upload files into a specific container in your storage account. The contractor should not have access to other containers or account keys. Which method should you use? A. Storage account key, B. Shared access signature, C. Azure AD RBAC assignment at the storage account scope, the storage firewall rules. Alright, so let's break this one down and let's extract the key phrases. And I'm really interested in temporary access and also uploading file into a specific container while having no access to other containers and also no account keys. Those clues are everything we need to tackle this question. Now let's walk through the option. Option A, storage account keys. And account keys give full control of the entire storage account. If you hand them to a contractor, you are effectively giving them root access. Every container, every service, that completely breaks the no account requirement keys and also violates the least privilege principle. So this one is out. Option B, shared access signature. And a SAS token lets you generate a temporary credentials with just right permissions. In this case, upload to one container only, but you can set the exact expiry date, limit the permissions to write or add only, and even restricted by IP address. Plus, you never share the account keys, and this checks every requirement, which is we want temporary and scoped access, which follows the least privilege principle. So we will consider it as initial answer and keep exploring the remaining options. Option C, Azure AD RBAC assignment as the storage account scope. RBAC is great for controlling access, and yes, you can assign roles like the storage blob data contributor. But if you look at the wording of option C, it says at the end, add storage account scope. So that means the contractors would get access to all containers in that account, not just the one we care about. That's too much access, and this is why it won't fit, and this is wrong answer. Option D, storage firewall rules. And firewall rules decide where traffic can come from, like limiting access to a VNet or IP range, but they don't decide who can do what inside the container. Firewall control network access and not upload permission, so this doesn't solve the problem, and we will consider the correct answer here to be B, shared access signature. So let's remember account keys, that usually means full control, and firewall is about network traffic filtration, not permissions. Next question. You plan to configure Azure File Sync between an on-premises server named Server1 and an Azure file share named Share1. The file share already exists. Drag the steps into the correct order, and we are given here 5 steps. So this type of question called drag and drops questions, and they came in Azure 104 exams. I would like to talk about how you actually approach this type of question before giving you the answer, because it's not about memorizing, and you will approach it the wrong way if you went just and try to memorize the workflow or the order of the steps. This is not efficient, and this is not how you should prepare for the exam. This type of questions is actually about understanding the dependencies between each step and the other. So you will need to understand this service, what the logic behind the correct order, and once you do that, actually it becomes easy to prepare for this exam. And also keep in mind, AZ-104 is open book exam or semi-open book, because you have access to the documentation of Microsoft. So it's better to approach it by trying to understand the logic and not memorizing, just like rote memorization. So for here in this question, for Azure File Sync, the logic is simple, right? First, we set up the Azure service, and then prepare and register the server, and then we create the sync group, and finally we add the endpoints. And now I will walk you through the correct steps, and also I would like you to pay close attention to the dependencies, because basically the first step I will just mention right now, everything depends on it. The second step, everything from the third steps and further depend on it, and this is why I mentioned dependencies. We need to understand which depend on which and what cannot be done until that step has been already done. So first step is create a storage sync service, and this is always the starting point in Azure, because every registration and endpoint attaches to a storage sync service. Without it, nothing else has a place to connect, so these steps come first. Step 2, install the Azure File Sync agent on server 1. Now I prepare the on-premises server, and you might ask what this agent do, and simply the agent is what talks to the storage sync service, and this means that I cannot register the server until the agent is in place. So this step comes second. Step number 3, register server 1 with the storage sync server. So registration links the server identity to the service I created, and only registered servers can participate in sync group. This is why this step comes third, because before I create a sync group, I need to register the on-premises server with the storage sync services. So it's actually a dependency of the next step, which is step number 4, create a sync group. And a sync group defines which endpoints will replicate with each other, and I create it after the server is registered, so I can add that server to the group in a later step, and this step comes fourth. And finally, we add a cloud endpoint for share 1 and a server endpoint for a folder on server 1. And with the sync group ready, I add the 2 endpoints, and the cloud endpoint targets the Azure file share. The server endpoint targets local path on server 1, so this steps comes last. So to recap, the correct order is 1, create a storage sync service, 2, install the Azure File Sync agent on server 1, 3, register server 1 with the storage sync service, 4, create a sync group, 5, add a cloud endpoint for share 1 and a server endpoint for a folder on server 1. Now let's move to the next question. You have a general purpose v2 Azure storage account named storage 1. You want to reduce storage costs for infrequently accessed blobs while retaining them. What should you configure? A. Soft delete. B. Lifecycle management rule. C. Immutable blob policy. D. Object replication. So let's go step by step with this question, and the requirement here is to reduce storage costs for blobs that are not accessed frequently, but we still need to keep them available. And option A, soft delete. And soft delete is actually about protection from accidental deletions. If someone deletes a blob, Azure can keep a copy for recovery if you enable soft delete feature. So this is about data safety and not cost optimization, and this is wrong answer. Option B, lifecycle management rule. And the lifecycle management rule lets you define policies that move blobs between tiers For example, we have 4 tiers in blobs. We have hot, cool, cold, and archive, and each one of them has different storage cost and access cost. And if you want to optimize cost, you can set up policies based on usage patterns, and then you can like optimize your storage blobs efficiently. So this is really promising. We will consider it as initial answer, but we will still keep looking. Option C, immutable blob policy. And immutable storage locks data for compliance purposes, so you cannot change or delete the blobs for the retention period you set. And this is great for regulatory requirements like financial or healthcare data, but it has nothing to do with reducing cost. Object D or option D, object replication. And object replication creates copies of your data in other storage account, often across regions, which improves redundancy and availability. But replication actually increases cost instead of lowering it. And in addition, it's not actually required in this question, so it's a wrong answer. And then the right answer would be lifecycle management rule. Moving to the next question, you have a storage account configured with LRS. You plan to improve availability and fault tolerance. For each of the following actions, select yes if it meets the requirement, otherwise select no. Statement 1, upgrade to ZRS. Statement 2, create a second storage account in another region. Statement 3, enable geo-redundant storage. And here, in this question, we are starting with LRS, locally redundant storage, and that means we have 3 copies of data, but all inside one data center. And the issue is if that data center failed, we will lose availability, and the requirement is to improve both availability and fault tolerance. So option or first statement, it's upgrading to ZRS. And what ZRS do and how it differs from LRS. With zone redundant storage, your data is synchronously replicated across 3 availability zones in the same region, and that's it. Only 3 copies, but instead of all of them being stored in the same availability zone, now they are spread across 3 availability zones. But that means if like the whole region or the whole like region goes down, you will still won't have access to those data. But compared to LRS, it's better. Why? Because with LRS, if the data center failed or has a failure, then your data lost. So now actually we improved by just upgrading to the ZRS. We will have an improvement in availability and fault tolerance. So this is a correct answer. And second option is create a second storage account in another region. So in real life, when you create a second storage account in another region, it could give you resiliency, but only if you also build your own replication or failover logic. But this is not a built-in redundancy feature. So it's not like something that comes out of the box. It's actually a manual solution you would have to script and manage yourself. On the AZ-104 exam, Microsoft only expects you to identify native replication options like ZRS, GRS, or AGRS. Because of that, this option does not meet the requirement in the exam context, and it's wrong answer. Third option, enable GRS, and geo-redundant storage keeps 3 copies in your primary region and 3 asynchronous copies in a paired secondary region. That way, even if an entire Azure region fails, your data is still protected, and this absolutely improves fault tolerance beyond LRS. So the correct answer, upgrade to ZRS, yes. Create a second storage in an storage account in another region, no. Enable GRS, yes. Next question. You have a storage account named storage1 that contains 100,000 blobs. You need to ensure that the users can read only those blobs that contain the blob index tag department finance. What should you configure? A. Shared access signature with tag filters. B. A stored access policy. C. A role assignment with a condition. D. A lifecycle management rule. So let's read this question one more time and highlight the key phrases. And here I'm interested in read only those blobs that contains a blob index tag department equal finance, and it asks me what I should configure here. So this tells me that we need an access control decisions that evaluate blob index tags at request time. That's the main thing we are looking for here. And looking into the option A, shared access signature with tag filter. And SAS control permissions like read or write and the time window. SAS cannot enforce a read access based on blob index tags, however. Right? So this is not a parameter we can configure. There is no SAS parameter that says allow only if tag equals department finance. So this is wrong and this is not solution. Option B, stored access policy. And stored access policy acts or sits in a container and governs SAS settings such as start time, expiry, permissions, but it does not filter requests by blob index tags and is still not meeting the requirements. C, role assignment with a condition, and Azure Airbag can use conditions that reference blob index tags. You can grant a data reader role and add a condition expression that allows access only when the blob has the tag department equals finance. This exactly aligns with the requirements. Because we can get, like as we said, that data reader role and then add a condition where we can actually select which department we want, or like decide the tag value that we want. For example, we can set it in a way to allow actions on certain departments. So this is really a great answer that satisfies all the requirements. But also let's keep checking the remaining answer, and there is one of them, which is lifecycle management rule. Lifecycle rules can use blob index tags to move or delete data across tiers or after a time, actually, which is good because we can reference the tag. But these are about data movement, not about who is allowed to read or write. So we cannot use it to control authorization. We can use it only to manage the data movement and retention. So this also a wrong answer. And then the correct answer is C, role assignment with a condition. Next question. You are configuring a storage account that must only be accessible from a specific subnet in your Azure virtual network. Compliance requires that all traffic remains on the private IP space of the VNet and no public internet connectivity is allowed. Which feature should you configure? A, private endpoint B. Service endpoint. C. Firewall rules with selected networks. D. Azure policy. This is a good question. So let's slow down and look for the key phrases on it. And here we are told access must come only from a specific subnet in a virtual network. And all traffic must stay on private IP space, and no public internet connectivity is allowed. Those clues should be enough, so let's test the option. Option A, private endpoint, and this creates a private IP address inside your VNet that maps directly to the storage account. Traffic flows entirely over the VNet, never touching the public internet, and this is actually very promising because that's exactly what we want here. But let's check others before jumping into conclusion. Option B, service endpoint. This is where many people can get tricked here, because service endpoint let you lock down your storage account to a VNet or subnet, but the traffic still goes to the service public IP, just tagged as coming from your VNet. And that means it doesn't fully satisfy the requirement of private IP space only. And while this is useful, it doesn't meet compliance here. So this is wrong. Option C, firewall rules with selected networks. And firewalls on storage account let you allow or deny traffic from certain VNets or IP ranges. But again, the endpoint is still public unless you combine it with a private endpoint. So firewall don't solve the no internet connectivity piece here, and it's wrong answer because of that. Last question is Azure policy, and policy is about governance. It can enforces rules like you cannot create storage accounts without encryption, or you must use HTTPS here. That's it, right? But it doesn't control actual network routing. So this option is off, which leaves us with option A, private endpoint. So let's move to our last question in this video, and it says your company has a compliance requirement to detect and respond to suspicious or malicious access patterns in Azure storage accounts. The solution must provide automatic threat detection and security alerts without requiring custom queries or dashboards. Which feature should you enable? A. Azure policy. B. Azure monitor with custom alert rules. C. Microsoft Defender for storage. D. Storage account firewall rules. So let's pull out the key phrases in this scenario. We are told the company has a compliance requirement. They need to detect suspicious or malicious access patterns in their Azure storage accounts, and also they said it must provide automatic threat detection and alerts without the team building their own dashboard or custom queries. And this is important detail here. We are not looking into custom or scripting solutions here. We want out of the box feature. So option A, Azure policy, and again, policy is all about governance. It enforces configuration rules such as requiring encryption or blocking public network access, but it doesn't watch for suspicious activities or generate alerts on behavior. So this doesn't solve the problem. Option B, Azure Monitor with custom alert rules. And Azure Monitor is powerful for metrics and logs. Yes, you could technically like write up custom queries and alert for the add access patterns, but the requirement in the question says automatic detection without custom dashboard. That's what was written in the question. So we cannot actually use this one here because it contradict or violate one of the requirements in the question. Option C, Microsoft Defender for storage. And this is exactly what the requirement is describing, because Defender for storage uses machine learning to automatically detect unusual access, and it can monitor and detect malicious activities, right? And it can generate security alerts and integrate with Microsoft Defender for the cloud. All this comes as out of the box, like you don't need custom rules needed or dashboards that you made by yourself. So this actually so far satisfies all the requirements in the question. Let's check option D, storage account firewall rules. And if you remember from a previous question, firewall restricts which network can connect to your storage account because it's about perimeter control, right? And this is what we need to understand, it's not about threat detection. So if a malicious, let's assume that we have suspicious activities and it come from allowed network, then those firewall rules will just do nothing, right? It's not their purpose to detect suspicious activities. So it's wrong, and then the right answer would be Microsoft Defender for storage. So this brings us to the end of our video today. Thank you for your time and for watching. If you find this content helpful, please subscribe, and also visit us at nilecertified.com for more resources, practice questions, and guidance on your Azure certification journey. Thank you so much and have a good one.